Okay, this is a pre-release video for lesson 11, how does a river change along its course? A lot of this is consolidating because you have done quite a bit of this either on the field trip or in your skills lesson. So it's referring back to the Bradshaw model and any notes that you have on that from your skills lessons, and I think even you might have done an exam question on it. So you need to know, one of the first thing you'll be asked to do in class is to recall, so you've got to learn these things, what happens to characteristics along a river's course. So velocity changes, velocity increases as you move downstream, velocity increases because of an increase in discharge and a more efficient river channel, a less rough river channel, so the river doesn't have to overcome friction, etc. So you need to know how velocity changes and why velocity changes. You need to know how discharge changes. Discharge increases because you've got more tributaries adding water to the main channel. Width increases downstream, depth increases downstream, channel efficiency, so the hydraulic radius tends to be higher downstream, indicating higher efficiency. Sediment load tends to increase downstream, friction tends to decrease, turbulence tends to decrease, roughness tends to decrease, the size of the sediment tends to decrease because of attrition and it's my phone. The gradient of the land, if you imagine the long profile drawing that you know about, the gradient tends to decrease. It gets a shallower gradient as you move towards the mouth. You need to know what velocity is, which I can't imagine is going to be a problem at this stage. You need to know what channel efficiency means and how it is calculated. So relook at the formula for calculating channel efficiency. You need to know what friction is, what turbulence is, and what we mean by channel roughness. On your pre-release, you are asked to draw the three valley shapes that occur along the three stages of the river, which is not difficult, it's learning, and you need to be able to draw and label those, so do that onto the sheet, please. You are also asked then to write why river valleys change downstream. Now, this is a past exam question, and we probably will do some work on this in class, so I'm not going to say too much, but think about why does it go from being a V-shaped valley to being a flat valley floor? What is happening along the course of the river? Why is it a V-shaped valley in the upper course? Why is it a U-shaped valley? And why is it a flat valley floor? It then asks you to review your work on the long profile. Just read through your pre-release from a couple of lessons ago or last lesson on the long profile and your work in class, and read through textbook page 21, please. That's it. We're going to be tackling quite a tricky exam question in class where you definitely need to have your brain switched on for map skills. So think about refreshing your knowledge on 6-figure grid references, 4-figure grid references, contour lines. What are contour lines? What do they tell us? Contour shapes. If the contours are close together, it means that the gradient of the land is steep. If the contour lines are spaced out, far apart, it means that the gradient of the land is fairly shallow or indeed flat. If there are no contour lines around at all, flat land. I think that's it. Happy work.